Hey everyone, it's AI Thursday here on the Techstrong Gang. We've got all kinds of good stuff around AI and sustainability and green and what's going on in tech. You don't want to miss it. You're watching Techstrong Gang. Hi everyone, good morning. It's Alan Schimmel from Techstrong Group and welcome to another edition of Techstrong Gang. It is an AI-powered, AI-themed edition here for this Thursday. We've got our AI heavyweights on here, experts, and we're going to talk a little bit of green sustainability as well. Let me introduce you to who we have on Gang today with us. Joining us as usual from Colorado, Techstrong CTO and Principal Research Analyst, Mitchell Ashley. Mitchell, welcome.
Good morning. AI Thursday. Yeah, baby.
Okay. Can't have an AI day without this next guy. It's our AI resident gang member, expert, Mark Hinkle. Hey, Mark, welcome from the, you could say where the company is, Mark.
Hey, good morning, Alan. I'm calling from the Outer Banks of North Carolina, a mobile studio, or I could be an AI-powered avatar. You'll have to decide for yourself.
Anytime, anywhere, everything. All right. Thanks, Mark, for joining. And it's, by the way, Mark's newsletter and stuff is the Artificially Intelligent Enterprise. And check that out. Joining me here in studio at Techstrong headquarters in lovely but rainy today, Boca Raton. To my immediate left, our green expert. She's a meteorologist, a author, as well as sustainability, Bonnie Schneider.
Thanks. Great to be here.
And then to my far left is our Chief Content Officer here at Techstrong, one and only hailing from the Bronx, New York, Mike Vizard. Mike, what do we got for today?
All right, well, let's jump in because tongues are wagging. I guess Dell had a call with the analyst folks in Wall Street and referred to a upcoming GPU that has 1,000 watts per GPU generated. I think that's pretty hot. What are you hearing, Bonnie, from folks about what's going on with AI infrastructure and wattage and climate? Because it seems like, these things are just going to generate boatloads of carbon.
Yeah, and I think that they're hotter, literally, than previously thought. NVIDIA's next-gen AI is reporting to be taking 40% more energy than originally thought. So now that we're seeing, okay, this is causing a lot more energy use, how are we going to keep things literally cool? And I think that's where Dell is coming in with some innovations in design, whether we are creating AI that not only is obviously going to tap into the power demand, but it's going to be able to cool at the same time. And I think that's going to be a key technology going forward.
I don't know, Mark, is AI killing the planet? You're into this pretty heavily, but there's a lot of folks, especially in Europe, asking tough questions.
Well, I think it's the key is how much work do you get for those watts? So when we look at the wattage right now, we're looking at how much power it's consuming. If you look at said, who's the CEO of NVIDIA, and their earnings, they were talking about a 20-to-1 efficiency in the amount of work for a GPU. The problem is that, at the rate that we're consuming AI, it may be more efficient than a CPU, but we may be just increasing our appetites. Another company out there, Grok, G-R-O-Q, they power the inference. So the sort of, when we ask ChatGPT a question, that's inference. They are supposedly doing 20-to-1 efficiencies versus NVIDIA. So it's not so much how much power they're burning is, how much power per amount of work. And that's remains to be seen.
So I have a few thoughts on this. Surprise. Number one, I think the cooling line of questioning is a red herring. We'll figure out the cooling, right? There's always this, how much processing power versus how do I cool it versus where do I store all the data it needs and generates and all of that stuff. That'll be figured out, and I'm not worried as much about the cooling. As a matter of fact, there's an argument to be made that the more cooling you have, the more energy you're going to need to produce the cooling as well. But however, I am really concerned just about our grid, about our capacity, right? This is what's slowing down electric vehicle production, right? I don't know how many of you have electric cars and have taken road trips. It's a pain in the butt, right? You wait online for too few chargers that don't work. And, it's kind of becomes a self-fulfilling prophecy here. The more successful AI is, the more capacity we're going to need to power these processors, whether they're 20 to 1, 40 to 1, or 100 to 1. We're going to need that capacity. And so between that and electric cars, fundamentally, we need a better mousetrap when it comes to electricity, right? And I don't know if the answer is building these new micro nuclear fission plants, or maybe we go to fusion, or we line up windmills from here to there. I don't know what the answer is, but we need to do something about the electric the generating capacity and the grid, not just here in the U.S., but around the world, if we're going to empower these new technologies.
Alan, what I was going to add is we're in an era where it isn't just, Moore's law and how many MIPS is this chip, going back a ways here, but if you look at the new designs of the chips, and this doesn't alleviate the power problem, but you have to also consider these are really systems on a chip. They're not just a CPU or a GPU. They've got onboard memory, and applications are built to leverage the fact that the architecture of the chip has changed. So we might be comparing maybe a small orange to a small apple, or a big orange to a big apple. I'm not sure. But it isn't as simple as saying it's this fast, because now you're essentially comparing a computer that's really in a chip.
So, Mark, Elon Musk is saying, well, we're going to run out of GPU capacity anyway, so maybe this won't be as big a problem because we won't have enough GPUs to run these workloads anyway. And
who cares what Elon Musk says?
I was going to say,
Mark,
when did that?
I just want to put that in there.
So, GPU is the sort of supply chain choke point right now, along with what you just said, Alan, is the, power considerations for data centers. Back in the olden days when I got started in the, mid 90s, the big choke point for data centers was bandwidth. Now the choke point is, power for those things. And I think you're right that power that is reliable near the data center is now the new need. And I think, Elon Musk is right. Sam Altman is right, is that we need to come up with a global supply chain for GPUs, and not just a supply chain, but a supply chain of efficient GPUs, which, every single bit of technology, as Mitch just said, has benefited from, miniaturization. So Moore's law was part of a bigger trend that was sort of kicked off actually before the space program, but the space program is what made us make that leap forward. Is we needed micro-sized processors that could go into space. If I'm hoping, and I'm an optimist some days, is that this need for AI technology will be the, moonshot for us to start reducing power consumption and improving efficiency, which, we're seeing it now.
That's exactly where I think this is going. We're seeing a greater demand for clean energy solutions and how to power all this. And that is something that I've seen from the interviews and people I've spoken to is, okay, we know we're going to need more energy. We need better energy resources than what we have right now. So there's a greater drive towards that. Also, though, with data centers, right? Some of the more forward-thinking data center operators, Google, Microsoft, and some of the dedicated, just pure data center players, they've anticipated this electric capacity issue and cooling as well. And they've been building data centers above the Arctic Circle, piping in cold air from outside to cool things down. They've been building data centers next to rivers so they can create hydroelectric, dams and turbines right outside the data center. So we have been. This is not a new issue. It's just, I think, the amount of electricity or the needs of this whole new generation of processors, is making it more acute.
But this is something that's been staring us in the face for a while. Can I just say a quick word on Elon Musk, though, too? So in addition to saying we have a GPU issue, he's now threatening, or maybe he is suing OpenAI because they went commercial on him. And it's come out now that when he originally wanted to get involved in OpenAI, he actually wanted to combine it with Tesla. And I can guarantee you, like everything else Elon Musk does, it ends up in making a buck for Elon Musk. And so, you know what? I respect what he accomplished and all the money he made, but let's face it, the boy's off the tracks now for a while.
Well, you know what? The OpenAI just released a bunch of emails from early back in the history of the company when he's involved in starting it. And there's all these email trails of, you've got to have a commercial offering. You can't fund this just by raising money. It can't stand alone on that. You've got to have a profitable company here. So, you know, he's not the first person to speak both sides of his mouth, but I think it's the money talking, right? He thinks he can influence something by doing that.
Regardless of Elon's sanity or not, Mark, we hear a lot about AMD's coming down the pike with GPUs soon. Is that going to alleviate the supply chain crisis, or what do you think? Is that a real thing? I mean, it seems like they talk a lot about it, but no one's seen one.
I think it's a short-term fix. I mean, I think that as much as that sounds crazy about Sam Altman's $7 trillion chip industry around GPUs, I think AMD coming in to the fray helps alleviate that. Because it takes, I think, 10 and 6 or 7 years to build a chip plant. So, you know, that's going to be at the scale that we need. So anyone that can get to market faster is going to alleviate that pressure. I mean, only time will tell when you see the performance of these GPUs under workloads. And, you know, there's two types of workloads. There's training and inference. And right now, the training is exponentially more resource intensive than inference. And, you know, we're taking all our data and training these models on it. And so, you know, we're getting hit from both sides of, you know, huge demand for more AI and a lack of GPUs. And that's creating, you know, a great business for an NVIDIA, who's now at almost a $2.5 trillion company.
Wow.
Yeah.
But we only use GPUs because they excel at parallel processing. They weren't really designed for these AI workloads in the first place. So my next question is, do we need new infrastructure, and I'll start with you, to drive these new applications? I mean, some folks are talking about photonics and optical systems and all kinds of things.
Quantum. You got to mention quantum.
It's unclear how we're going to manufacture these things at scale, but you know, you talked about space. Do we just need a new approach here because the existing stuff isn't going to make it?
Yeah, I think a new approach is good, but I think that as we take these new approaches, one of the key factors will be, going back to what you were saying earlier, is cost, is that we're able to do this in a way that's cost effective and also minimize the use of energy. We were talking about that previously as well. When architecture changes, we're able to do more with less, create more processes that are automated. That's great, but what is the cost of it? And will it, in the end, bring about reduced energy use? I think some of that will remain to be seen as we move forward.
Look, you know, we're not driving model. I'm sorry, go ahead, Mitch.
I think the other thing is we can't use the Intel model as how innovation is going to move in this era of AI chips. I think we're going to see architectural changes very rapidly, like the current HPC, the H100, H200 era of chips from NVIDIA. I'm not in the inside of what's happening in their product planning, but I got to imagine it isn't just going to be an 8086 to an 8088 to a blah, 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 blah. I think we're going to see real architectural changes and innovations of what's happening on that chip, not just packing more into it and thus consuming more power.
Right. I agree, Mitch. The Intel architecture was very much linear, packing more, gates into a thinner and thinner and smaller footprint. I think in AI, though, you got to remember we're still early in the game. Yeah. Right now, we're using a butter knife instead of a screwdriver, right? Eventually, we're going to develop a screwdriver that works better on screws than using your butter knife out of the kitchen drawer that your wife yells at. Don't ruin my butter knives. So I think that sort of innovation is going to happen, and it's coming quicker. Will it alleviate all these problems? No, because it'll be incremental. But 5 years from now, as Mark mentioned, when some of these new foundries are on and everything else, this will be an early days problem.
Before we end this chat, though, I do want to note that AI isn't always the bad guy here, right? We have folks in Abu Dhabi's oil company is talking about how they're taking 1 to 2 million tons of carbon out of the environment because they used AI to optimize everything else they have. So, there's
there's a reason why everyone's excited, right? It's supposed to, this is the promise of it. That's why we're, otherwise, who wants to listen to us talk, right? AI is supposed to be doing these kinds of things. Here's some proof of it.
There you go. Mark, last words on this.
Yeah, the one thing that I think we should think about too is, and you touched on it, is maybe the paradigm shifts. I honestly think that in the long term, NVIDIA may not be a hardware company. They may be a software company, because the thing that they did for, this parallel processing has come up with something called CUDA, which is the Compute Unified Device Architecture. This is the sort of the VMware for GPUs that lets it run across different architectures. So, I think Alan's right in the fact that, and I hate being that agreeable, but he's a smart fella.
Thanks, Mark. It's a little something extra there for you.
Well,
in the RV.
You don't have to do that. You'll get to come back, Mark.
Yeah, we'll invite you back.
we can argue about open sourcing CUDA when you come back next time. How's that?
Yeah. But you know what? Right now, we need to take a break here on Techstrong Gang. We'll be right back. All right, we're back here on Techstrong Gang, moving on to our second block, as we call them. Mike, you want to introduce this one?
Yeah, so there's a report from Cast AI, did an analysis of how Kubernetes clusters are being consumed in the cloud, and surprise, surprise, they discovered that there's a lot of over-provisioning, which leads to lots of extra carbon being generated for no apparent purpose. So let's just get started here with, level set us a bit, Mitch, but why do developers constantly over-provision? This has been going on for decades. It's kind of an open secret. I mean, what is it that they don't seem to care about the environment, or is there something else at work here?
Well, I find it interesting that we don't have more studies about this, given sort of the numbers coming out of this Cast AI report. They quoted numbers like from 1,000 to 30,000 processors, they're only using 17% of capacity. That's a pretty big range. So I'm not sure what to make exactly of the numbers. I suspect it's partially knowing how to optimize. I mean, Kubernetes is complex to use and set up, et cetera. And oftentimes people are using the additions, if you will, that come through the cloud service providers or others. And, developers don't spend their time on efficiency most of the time. They're working on capabilities and fixing issues and security. And platform engineers and SREs tend to more focus on that. So maybe that's where the opportunity is to really develop some great Kubernetes chops in other parts of the team to help make kind of a holistic answer to how do we better utilize those resources.
I'm a little more cynical about it. I think developers don't want to be woken up at 2 o'clock in the morning, so they just get as much memory and storage resources as they can get because they want their application to always be available. And they just, they turn the button to 11 every time.
I say stop blaming the developers. It's an ops issue, right? And, the developers, yes, there are shadow IT where developers are setting up the infrastructure. But in today's enterprises where a lot of this waste is happening, there are platform engineers, the new darlings, right? Platform engineers and ops folks who are setting up the infrastructure that the developer's code runs in. They put in the guardrails. I think the bottom line is this. This is why there's a whole fintech industry. Forget Kubernetes for a second. The cloud, and on purpose, makes it far too easy to spin up wasteful instances and over provision your resources, and then makes it far too hard to say, wait a second, I got all these instances that I'm only using 17% of, or I'm not using it all. Shut it off, shut it off, shut it off. To me, this is a fintech problem.
I think you mean FinOps.
FinOps, excuse me.
There you go.
Fintech's different.
All right,
excuse me.
Well, let me ask you, I mean, are the cloud service providers somewhat complacent in all of this from a green perspective? Because, they're like, yeah, we want just more workloads.
Well, I think that there's also a shift of education to show how to do green coding, green software. I speak to the Green Software Foundation a lot, and they're actually growing quite a bit in membership and organizations wanting to fix this problem using less resources and having more efficient coding. So that's something that I think we're just talking about AI and learn as we go, but I think the green computing, green cloud, that's also something that's evolving to better use resources and waste less energy.
There's another approach to this too, and that is, full disclosure, I'm doing some work with AWS serverless organization, and that is taking the Lambda type approach where you don't provision things ahead of time. That's controlled through the infrastructure and dynamically provisioned for you. Yes, there's some things involved in configuring that, and of course they have their Fargate offering, which is their Kubernetes based to run workloads. Containerized workloads. So there are other approaches too than just sort of throwing raw Kubernetes at it too. And maybe those we'll find the best applications to use for Lambda and other serverless options from Google and AWS and Microsoft.
Mark, we have all these AI models with all these parameters. Do they need energy ratings? Can we figure that one out?
I think it's way too early, Mike. Things are changing on a weekly basis for that. But I would like to go back to the whole Kubernetes thing. Think about this. We started out, it's a cloud infrastructure. It came out of Google, and it was built at a time where Google couldn't grow fast enough to handle the demand for that. Amazon, all the other cloud providers adopted Kubernetes, but they're the utility. Then we realized that we were overspending on cloud. We started to repatriate workloads in the data center. They were running heavier full virtualization, and now they're going to containerized. So they're using the same infrastructure and the same provisioning model with something that is 5 times more efficient. So, Charlie Munger always said, show me the incentives, I'll show you the result. And the result for the developer is, I don't want to be called in the middle of the night, as Alan said. So let's over provision, keep the data center up, but the developer isn't on the hook for the power compute bill and over provisioning. When it comes to AI models, I think that they're going to run in some kind of virtualized workload. I think CUDA from NVIDIA is the way they'll do it, but for now, AI is probably not as big a player in that as just regular workloads running in containers at the application layer.
I think there's a large number of AI workloads running on those Kubernetes clusters already, but maybe not as many other workloads. But Mitch, Kubernetes was supposed to scale up and scale down. It seems like it scales up but never comes down. Why is that?
You still have to kind of define what the parameters are for the cluster to be able to scale up and scale down, and how rapidly it does that, right? Because it's not all sitting there to instantaneously use. There's this thing called cold start, right? Especially in the serverless world, which is that time it takes to spin up the infrastructure to catch up with the workload, or pre-provision a certain amount ahead of that. Maybe we're just over provisioning how much is sitting there ready versus what would dynamically be spun up as workloads. It's a good question. I'm not running a big Kubernetes instance or workload to share any personal experience with it, but it seems like it's a place with definitely a lot of optimization left to go after.
I think, why make Kubernetes the whipping boy here? This is the problem with the cloud in general. This whole elasticity thing is one way, right? Unless you're really using FinOps
Yeah.
solution, no one turns their stuff down. No one. And the cloud providers like it that way. What do you want them to send out reminders? Right? So this is what it is. It is what it is. And again, I think that's why there's a whole cottage industry around that. But can we build that into Kubernetes? Perhaps, right? To have that two-way elasticity. But it's been a problem before Kubernetes, and it'll be a problem after Kubernetes, I'm afraid.
There are companies that specialize in this, Stormforge, and you could list a whole bunch of companies that focus on more efficient use of Kubernetes. So it's kind of driving its own cottage industry.
Yeah.
You hear this conversation? Do you think we're serious enough about all this stuff? Because I don't see that little energy consumption button on the console when I'm monitoring my environment just yet.
No, I don't think so. I think there isn't, that is not happening. But there are more companies that are providing tools for organizations to monitor energy use, especially within IT departments. From what I'm hearing is that they're getting more pressure to reduce costs and monitor the energy at the same time, which isn't always something that's innate that they would know to do. So,
Cool. Are we done on this one? Can we
I think we can move on to our
All
next
right.
topic.
Hey, we're going to go to our next topic here in just 30 seconds. You're watching Techstrong Gang.
DevOps.com is the #1 online destination for DevOps education and community building. DevOps.com covers all aspects of DevOps, including DevOps best practices and tools, DevOps culture, DevSecOps, business impact, continuous testing, continuous delivery, and more. DevOps.com has the largest collection of original DevOps content, featuring breaking news, blog posts, podcasts, and more. Visit www.devops.com to learn more. DevOps.com, where the world meets DevOps.
All right, we're back with our green theme, and now we're moving on to a lawsuit that's floating around. Can you imagine that there was lawsuits involving energy and IT? I'm shocked and appalled. But apparently the Texas Blockchain Council is suing the Department of Energy because the Department of Energy had the temerity to ask the local blockchain operators in Texas, how much energy are you consuming? And I guess the Blockchain Council basically told the DOE, it's none of your business. And then they went to court over this, and lo and behold, they got a restraining order. And so here's my question to you. What is that fine line legally here? I mean, if I'm running a data center, who do I got to tell and why do I got to tell them this? Because it seems like there's no case law here that says, yep, you're responsible for this and the DOE is authorized, because it doesn't look like they are.
I think that there is a fine line of what's considered privacy to run your crypto operation that you're doing, but I also think that there's a reason why the Department of Energy is trying to keep track of this energy surge for other reasons as well. When you have so many different resources tapping into the grid, especially you mentioned in Texas, where there wasn't too long ago where we had major outages during a winter storm. I think transparency is key. We have to know what are these different demands on our energy grid that's happening, because in the worst case scenario, it could be too much and they're not prepared for it.
I don't disagree that we need to know, but I don't think we have any legal right to know just yet, because all this stuff has not been put into any legal document from Congress. It's been a agency seems to be extrapolating its authority a little bit and saying therefore we can collect. We have seen agencies.
Are you calling for smaller government?
I am just pointing out the fact that the Supreme Court has made it pretty clear that they don't really dig this agency overreach, shall we say, whether you agree or disagree. But do we need Congress to show up here? Maybe Mark or Mitch, you want to throw some thoughts in here, but do the people who make the laws even understand what we're talking about?
I think you hit it right on the head. It's a public utility. They should be able to instrument their power usage from the grid. I mean, it's a public utility, unless these crypto guys have their own little fission plants in their backyards, or maybe they're hanging out with Alan's buddy Elon Musk and doing Solar City installations.
He's in Texas too.
That's right.
Yeah, but I mean, it's a weird thing, because I don't understand why they wouldn't just instrument their grid, and they should be doing that anyhow to make sure that the grid doesn't go down while their senators are partying in Mexico.
That was during that storm, actually.
Absolutely.
I was talking about.
So there's a few things at play here, though. First of all, who the hell is the Texas Blockchain Council?
I didn't know there was one.
Who the hell thought that was a good idea?
Right? The Texas Blockchain Council. And look, if they would just grab an electricity from the local utility provider, we got these things called meters. It would make it real easy to see what's going on. I suspect, like most crypto mining operations, is they're getting energy off grid somehow, or someone else's energy on someone else's meter, and maybe that's what's really at play here. But the other thing, in this instant case, it wasn't like they were served with a subpoena or they were put under arrest or anything. They were asked to just fill out a survey so that the agency can better ascertain what are the energy needs in a state that frankly has had energy need deliverability issues, all kidding aside. So this wasn't a case of, people peeping in the bedroom and bringing potential sodomy charges or something. We just wanted to know how much energy you're using so we could provision for it potentially. It'll be interesting to see. Now, the court's in Texas, so you can imagine which way this is going to go. But eventually, hopefully, it gets brought up to some federal appeals court level, and it'll be interesting to see which way it goes.
Well, there's other uses of that information. So I'm going to take a left turn, but it ties to this. Yes, I'm from Colorado. I have to bring up cannabis. In the cannabis industry, one of the things they use to detect illegal grow operations is energy consumption. Both heat coming out of a particular location, like someone's home or their basement, or someone stealing energy from their neighbors, right? Just tapping into a place to plug in and go run all their grow lights or whatever you do to run a cannabis operation. So this data could also potentially be used for saying, now, what's going on here? This cryptocurrency company, everybody else uses about this much per these many transactions, but these guys are doing something different. Why is their energy consumption going so high? Maybe that's where the Russian and the whatever and the money is flowing off continent, and black money is being exchanged on the black market or whatever. So not that I'm saying that's happening, but this information is more than just the altruistic. Oh, let's see how much consumption everybody's using. It could be used for other purposes too.
Do you think?
And that was 100% my point, Mitch, is that asking for the information and monitoring it, it's lawmakers that don't have the technology understanding to know. And I was thinking the exact same thing you were, because where I grew up, that thing is, the DEA would come into places and they would track, the frequency of those grow lights is communicated across power lines. They could be doing the same thing for GPUs and crypto mining, and it would be a better indication of the trends than asking some middle manager to fill out a survey on, and Alan hit it on the head. What the hell is the Texas Blockchain Foundation, whatever? I mean, it's ridiculous.
You don't think
that
they
came
have
from
standing?
the random committee generator algorithm?
Let me ask Bonnie here, though. Do you think that because of what's going on with AI and what's going on with blockchain is the very reason why he can't charge his car?
Oh. I don't know if there's a direct correlation to that, but there definitely are issues. Now, this is just a weather aside. Sometimes, in colder locations, you have trouble with that. But I know we're in Florida, so that's not the issue here. I think that it all ties together, because we're talking about how AI is using even more energy than expected. So monitoring what, as Alan calls them, the crypto guys are doing, makes sense to be able to gauge for these outages, particularly as we said in Texas. So I'm not sure of the connection to the actual charging, but I think that nobody wants to lose power for any reason, especially if you depend on it to drive. So just a better understanding of as these things evolve, what energy is being used, how much, and keeping track of it, even for this organization in Texas, could actually help them when they want to charge their cars.
But there's also, and thank you for bringing it up, Bonnie. And for those, I'm going to assume most of our audience out here is familiar with how crypto mining works. But basically, you're running the algorithms to figure out the value of a particular blockchain, of a particular Bitcoin or whatever you're mining. And if once you get it, you get that coin, right? $20,000, $40,000, whatever Bitcoin goes for these days. Now, there's always like this ratio of how much computing power it costs you to figure out that entire algorithm and get that Bitcoin. And notoriously, Bitcoin miners don't want to pay the VIG over here for that electricity. So they're always looking to grab some free juice to do their mining and lower their cost. And that's really my suspicion. And I'm not familiar with the good folks at the Texas Blockchain Council, but I am familiar enough with Bitcoin mining to know that that's probably what's happening.
This leads to crypto jacking, where people steal compute resources in the cloud, and too many IT people think that that's a nuisance crime, but it all adds up to these.
And absolutely, it's a nuisance until it's not. So that, these Texas Blockchain Council are not angels, I'm sure. Poor woe is me, God help me from the big bad government. But anyway, as I said, the courts will decide it.
I have decided one thing. The people who are going to make a lot of money off all of this are lawyers.
Don't they always?
Of
Don't
course.
they always?
Yeah.
No doubt.
All right. I think that's what we have on our call for today. Mark, before we wrap up, though, I'm going to embarrass you a little bit and ask you to give us a little promo for this great virtual event we've got going on in late May.
Yeah. So May 21st, we are going to have the 24-hour Artificially Intelligent Enterprise online conference. We're going to have over 70 speakers, executives, practitioners. We have from, analyst firms like Gartner, coming from public companies. We have a few surprises. CEOs of a couple of public companies are going to speak, as well as people that are actually using Gen AI to solve real business problems. And I think this is the first of its kind. It's how to use AI for practical purposes other than heating up the planet and making us hotter than we should be. But I'm really excited about it. So
where can people go?
Tuned. It is the AI enterprise.online, or I think it's going to start showing up on the Techstrong.ai homepage shortly. So
there'll be links off
tuned.
Techstrong AI. I think there's already links off of TechStrongEvents.com, but it's the AI Enterprise dot what?
Online.
AIenterprise.online. You can go right there as well. We're looking for, full disclosure, we're partnering with Mark on this. We're helping on some of the back-end productions and so forth. But the speaker lineup is amazing. You don't want to miss this one. May 21st, you said?
Yeah, May 21st.
And it's all day, man. 24 hours. Follow the sun. Don't miss it.
Yeah.
Very cool. That's going to call a wrap to this edition of the Techstrong Gang. Mark, thanks for joining us from the beach there. Mitchell, Rocky Mountain High, power on. Bonnie, Michael, thanks
Party
for
on,
joining.
baby.
Yep. Thanks for joining us here in studio. We'll be back on Monday, right? We usually take off Friday. Those guys in Colorado, it's hard to get them in on Fridays. But we'll be back on Monday with some fresh Techstrong Gang. Don't miss it. Until then, this is Alan Schimmel. We're out.